Welcome to today's lesson. At the top of your paper, it should say multiply and divide whole numbers, single digit by multi-digit multiplication with partial products and the standard algorithm. Let's review. Yesterday, we used an area model to find the product of a problem similar to 4 times 27. Don't forget, you can break that 27 up into each place value. Go ahead and work this out on your whiteboard. We can break that 27 up into 20 plus 7, together still getting that length of 27. Well, I know the basic math fact of 2 times 4. Well, 2 times 4 gives me 8. From some of the patterns that we saw yesterday, I see that that 0 behind my simple math fact is just the amount of zeros that I would put behind the product of my simple math fact. Here, 7 times 4 gives me 28, and I simply add the two areas together to get my total area of 108. So 4 times 27 gives me an answer of 108. Today we will review multiplying a single digit by multi-digit number using partial products and their standard algorithm. Okay, partial products are super similar to what we did with the area model. It just looks different, but the math that you're doing, the numbers that you use are all the same. Okay, so let's take that problem that we did earlier with our 4 times 27, and we're going to just show it in a different way. Okay, so on this side, I'm going to show you partial products. Okay. So I'm going to look and I say that 4 times 7 gives me 28. With partial products, you just write the whole number that you got when you multiplied down below. Okay, so I did 4 times 7 to get 28. Now I'm going to do 4 times this 2. But what's the real value of that 2? That 2 is really worth 20. So 4 times 20 gives me 80. Sometimes we'll make a little note on the side so we know what numbers I was using to get these numbers over here. Well, then I simply add those together. 28 plus 80 gives me a total of 108. Notice how I still have 4 times 27, what I originally started with. I have the number 28. I have the number 80. It's all here. It's just in a different format. This method is called partial products, and this method is called the area model. Very similar, aren't they? So let's look at this next problem here. 6 times 48. We're going to find the product, which is the answer to a multiplication problem. Our first way of showing it is going to be partial products. We're going to multiply 6 times 8. Well, 6 times 8 gives me 48. I would write, if I were you on the side here, that this is what 6 times 8 equals. Just a little note so you know what that number came from. Okay, I see this 4 in 48, but what's the real value of that 4? It's not just a 4, it's actually worth 40. So here I have my 6 times 8. This is my 6 times 40. That's my 6 times 40. I did my 6 times 8, which was 48, but 6 times 40, that 4 is in the tens place, which means it's worth 40. 6 times 40 gives me 240. We add those together, getting a total of 288. 8 plus 0 is 8. 4 plus 4 is 8. 2 plus nothing gives me 2. 288. Now, this again is review for you, but let's review a little bit. Okay, this is the way that we get that same exact answer, but we use the standard algorithm. Okay, the same exact answer. It just looks a little different. We're honestly using the same numbers. It just looks different. Just like the area model, it looks different, same numbers. So we're going to start and we're just going to do 6 times 8. Well, 6 times 8 gives us 48. I wrote the 8 down here and I wrote the 4 up here. Well, why did I do that? My original answer when I did 6 times 8 was 48. Why do I have that red 4 up there? What does that red 4 represent? Well, in 48, that 4 is in the tens place. So when I write it above the 4 here, it's in the tens place. I'm taking it above the tens place. So later on, I will add that 4 with my 6 times 4. Okay, let's keep going. It represents those 4 tens, which I'll deal with later. Okay, now here I did my 6 times 8, and then the next step is I do my 6 times 4. 6 times 4 gives me 24. Oh, look, I see a 24 right there. 6 times 4 gives me 24, and then I'm going to add this 4 to get my final answer of 28. 6 times 4 is 24, plus 4 is 28. So now I have 28 tens. I multiplied 6 times 4 tens. When you think of it in units, it makes a little bit more sense sometimes. 6 times 4 tens gives me 24 tens. Well, I had 24 tens, and then I added that 4 tens here to get a total of 28 tens. What is similar and what is different between these two methods? What's similar is I got the same answer. And mathematically in my head, I'm getting these numbers too. Okay, what's different is it looks different. Instead of me writing the entire number here, I regrouped so that way I'd have to show less work. Eventually, when we get to 3, 4-digit numbers, this standard algorithm really does save a lot of work for us, because otherwise this list of numbers to add gets very long. Use partial products, again similar to the area model, to find the product of 8 times 63. Pause the video. Here we go. 8 times 63. 8 times 3 gives me 24. We write the whole number down for partial products. The whole thing goes underneath. 8 times 6, well, the value of that 6 is actually 60, or 6 tens. 8 times 6 gives me 48, but 8 times 60 is 480. Then we can add those numbers down. 4 plus 0 is 0. 2 plus 8 is 10. And 1 plus 4 gives me 5. So we have an answer of 504. Now I'd like for you to try the standard algorithm. I know you already found the correct answer, but I want to see if you can show your work to represent this answer using the standard algorithm. Go ahead and pause the video if you haven't already. Now we're going to do 8 times 3, which gives me 24. But instead of writing the whole number 24 down here, I'm going to write the 2 up here and the 4 below. Still has a value of 24 because this 2 represents those 2 tens. Then we multiply the next place value. 8 times 6 gives me 48, or 48 tens. Those 48 tens plus 2 tens gives me 50 tens. That 50 represents 50 tens. So again, here is the partial product way of solving, and here is the standard algorithm way of solving. Find the product of 9 and 421. Let's do our partial products. 9 times 1 gives me 9. 9 times 2, but that 2 is actually a value of 20. 9 times 20, let's see, 9 times 2 is 18, so 9 times 20 would be 180. 9 times 4, well, that 4 is actually a value of 400, so 9 times 4 gives me 36, but 400 has 2 zeros behind it, so then I'd have an answer of 3,600. Add those numbers together. 9 plus 0 is 9. 8 plus 0 is 8. 1 plus 6 is 7. And 3 plus nothing is 3. Okay? And like I said, I would go above and beyond and make a little note for myself that each of these numbers represents this math problem here. That way I know where they're coming from. Do you have to do it when you're actually showing your work? No, it's fine if you don't. But this is for our notes so that we know where these numbers are coming from. Later on when we look at it, we want to say, how did my teacher come up with those answers? And we have that information here. Okay? Standard algorithm. Again, same math, same numbers we're going to use. We're just going to write them down a little differently. So 9 times 1 will give us 9. Nothing to carry over or regroup here. 9 times 2 gives me 18. Okay, I wrote the last digit of the number I came up with at the bottom, and I regrouped that first number to go on the top. Okay, what does the 8 represent that I wrote down here? Well, that 8 represents 8 tens, right? Because the 2 is in the tens place. Now the 1 is in the hundreds place. So this 1 represents 100. Okay, let's keep going. Multiplying the next place value, 9 times 4 gives me 36. But it represents 36 hundredths. 36 hundredths. And 36 hundredths plus 100 gives me 37 hundredths. 37 hundredths. Why do we add the numbers at the top that we've written after we've multiplied? Well, if I added them before, that's going to completely change my product, right? Because here, notice how I came up with that number 36. We added that number 1 to the number 36 after we had done our multiplication. Same thing here. I multiply 9 and 4 first to get my 36 and then add 1. This is something we're adding to it. It's being regrouped. It is not part of the original multiplication. Okay, you guys are going to try 6 times 734. Pause the video. Use partial products. Welcome back. Okay, so 6 times 4 gives me 24. Remember, partial products, we write the whole number below, and we can easily see how we came up with these numbers. We have 6 times 3, but that's really 6 times 30. 6 times 3 is 18. There's 1 0 behind in the 3 and the 30, which gives me 118. 6 times 7, well, 6 times 7 is 42, but that 7's actually worth 700. So 42 with 2 zeros behind it would give me 4,200. Now we can add these together. 4 plus 0 is 4. 2 plus 8 plus 0 is 10. 1 plus 1 is 2 plus 2 is 4. And 4 plus nothing is 4. So our final answer is 4,404. Okay, let's try to use that same math problem. We already know the answer. It's just we're going to show our work differently. So on this one, you're going to be correcting how you've shown your work. Go ahead and pause the video so you can try it in standard algorithm. Alrighty, here we go. 6 times 4 gives me 24. Notice how the last digit is written below, the first digit is written above. 6 times 3 is 18, so I have 18 tens plus 2 tens, which gives me 20 tens. But we're not going to write the whole 20 down here. We're just writing the last digit and regrouping. 6 times 7 is 42. 42 hundredths to be exact, plus these 2 hundredths. 42 plus 2 gives me 44 hundredths. We are left with 4,404. Notice we got the same answer, we just showed our work a little differently. This is the last example I'm going to show you. Find the product using the standard algorithm. Oh my goodness, we're bypassing the entire partial products for this problem. 236 times 4. We write it vertically. That's how you should always be writing these multiplication problems. And we have 4 times 6, which gives me 24. Again, the 4 is the last digit. The 2 we had to regroup. What does that 2 represent? That 2 represents 2 tens. Why is it written above the 3? Because the 3 is in the tens place also. So I'm going to make sure that I add the same units together after the multiplication is done. I add ones to ones, tens to tens, hundreds to hundreds. Okay, so we'll continue on. 4 times 3 gives me 12, and 12 plus 2 gives me 14. But it's 14 tens. So we wrote a 4 in the tens place and we regrouped that 1 because we know 14 tens is the same as 104 tens. Okay, 4 times 2 gives me 8 and 8 plus 1 gives me 9. I got 4 times 2 being 8 hundredths. 8 hundredths plus 100 gives me 944 as my final answer. Why do we add the numbers that we've written on top after we've multiplied? Because just like we did in partial products, we add those different products together at the end. Okay, go ahead and pause the video. Find this product using the standard algorithm. Here we go. 6 times 3 gives me 18. Write the last number below, the other numbers on top. 3 times 3 gives me 9 tens, and 9 tens plus 1 10 that I regrouped gives me 10. So 10 tens is the same as 100. So I have a 0 here and I have a 1 in the hundreds place. 3 times 5 is 15, and 15 hundredths plus 100 gives me 16 hundredths. So 1,608 is our final answer. What are some methods or strategies that you can use to multiply a single digit and a multi-digit number? Well, you can use the area model strategy, you can use partial products, you can use the standard algorithm. What's different about those strategies? Well, the biggest difference is how you write them. Okay, what's the same about those strategies? You're multiplying and getting the same numbers, you're just writing them a little differently. Find the product of 42 and 7. On this one, you can use whatever strategy you'd like. Go ahead and pause the video. I'm going to use the standard algorithm. 7 times 2 gives me 14. 7 times 4 gives me 28 tens, and 28 tens plus 1 10 gives me 29 tens. 294 is our final answer.